Hey, what's going on, guys? Let's do this problem right here. The question is asking the potential as a function of position is shown in the graph in the figure. Which statement is true about the electric field? And here they have given electric field is 0 at which point, and what is the in which case magnitude is maximum, right? So magnitude is maximum and electric field is 0. We have to find these 2 points. And if you notice, this is dV by dx, so electrical potential in terms of the distance. And here if you notice, this is flat right here, right? So it means at this point potential is flat. It means electric field is 0 at this point. So E is 0 at this point. So it means it is true one of these conditions, like this one also says x is equal to 0. Electric field is 0 at x is equal to 0, and here we have another one saying electric field is 0 at x is equal to 0. So these two statements comes out to be true. And let's check with the other one. X is 0 at 10, so this also seems true. At 10 also is like flat. X is equal to 0 at 5. At 5 it's not true, because so we know this statement is not going to come as our answer, because at 5 this is a slope right here, so at 5 it's maximum. At 5, because if you see the slope is going steep, it means the electric field is maximum at this point. So this is maximum, right? Max. So let's check at the other part. Magnitude is maximum at x is equal to 5. Yeah, this, and directed to this. Okay, this part is true. Here also this part is true, and this one we don't have to look at it. And x is maximum at x is equal to 15. So 15 also, like there's a steep line right there. So at this point the slope is here also, it seems maximum. So let's see the other part. So this one also seems kind of true, and the field is directed to the left there. And if you see the before the 10, the electric potential is lower, and here it's higher. So it's never go from lower to higher, it's go from higher to lower. So this one is not true. It's not. It's actually it's equal right here. So here is equal. These two sides are equal. This doesn't make any sense, right? So let's look at this one right here. Electric field is directed to right. So before 5, it's like this is electric field is high before the 5, and after 5 is low. So going from high to low, going right side. So this one is correct. So let's look at the other one. Electric field is directed to left after 15. 15 is higher, is lower. To left, 0, maximum at 15. But the thing is, compared to this and this is not the maximum. If you compare this one, 15 and 5 is going to be the maximum, right? So therefore this statement is not true when we compare with this one. So this one doesn't come true, therefore the answer for this one is this part, right? So that's how we can analyze and find it out, right? So let's look at the other one. A negative charge is moved from point A to B along an equipotential surface. Which of the following statement is true for this case? So work is both required and perform is moving in a negative charge from A to B. So let's see what happens to work when we have equipotential surface. So when we have equipotential surface, delta V initial minus final is going to be 0, because equipotential means the potential is going to be same everywhere, right? So this is going to be 0. There's no difference. So if this one is 0, we know that W is equal to Q delta V. So if this one is 0, then work is 0. So there's no work required. So here they are saying work is both required and performed. So this is not true. The negative charge performs work in moving from, okay, performs work, not true. No work is required to move the negative charge from point A to point B. This one seems right. Let's look at the other one. Work is required to move the negative. So this is also not true. So the answer for this one is C. And that's how we can do this kind of problems. I hope you guys find this video helpful. Thanks for watching.